So today we are doing our second mission, mission 2b. I can write and graph a linear equation, so we will be using tables to graph again, but we're going to focus on proportional graphs today. A proportional graph ultimately just means that it goes through the origin, or the middle of your graph. That point would be 0, 0. So on the graph, if it goes through the middle, we call it proportional. A graph that is not proportional does not go through the middle. This one begins up a couple points on our y-axis. Okay, so that's the only difference between proportional and not proportional graphs. In the form of an equation, we have a proportional graph just tells us these first, the number and the x tell us the angle really of our line. You don't really need to worry much about that. This second piece of information, if we have a plus or a minus something added on, that tells us that our graph is not going to go through the middle because this graph begins at a positive 2. This graph has nothing added on to the end, so we know it begins at 0 in the middle. So the only difference between our two equations is that if it has plus or minus, you know it's not proportional. In the form of a table, these are our points x, comma, y. And we know that if a graph is proportional, it goes through the origin. So if it has the point 0, 0, it's proportional. But if it doesn't have the point 0, 0, we know it's not proportional. Okay? So those are the differences between proportional and non-proportional graphs. So we're going to look at this first one. Just by looking at the equation, there's nothing added or subtracted on the end, so I know this is proportional. Yes, it's going to go through the middle of my graph. So let's take this equation and graph it. First, put your equation right in the middle. We have negative 2x. When we plug in a number for x and solve our equation, it will tell us what y is. So that's why our third column over here is for y. So anytime I plug in an x, I'm going to plug it in right there. We have negative 2 times x, and x is negative 2. So remember, we're taking out the letter x and replacing it with whatever x represents. First, it's a negative 2. And I know we're multiplying because they're touching. If you want to put it in parentheses, you can. So I know every time I'm going to start with the number negative 2, and I'm going to be multiplying it by whatever x is. So if it helps you to set up your problem first, you can. Then x would be a negative 1, then x is 0, then x is 1 and 2. So you're just multiplying by a different number each time. So first, negative 2 times negative 2. A negative times a negative makes a positive. Then same thing here. Negative times a negative makes a positive. 2 times 1 is 2. 2 times 0 is 0. Negative 2 times 1 is negative 2. And negative 2 times 2 is negative 4. You can also see a pattern. We go down by 2 each time. Alright, so let's plot these points. Uh-oh, what did I do? Oops, I lost my... Oh, they disappeared behind here. Sorry, guys. I'm just going to minimize this for now. So we have our points. Negative 2, negative 1, 0, 1, and 2. So here's our first point. Negative 2, up 4. So remember, x is left to right first, then up and down. So negative 2, up 4. Then negative 1 to the left, right here, up 2. Then, oh, here's that 0, 0. That tells us it's proportional. We have the point 0, 0. It means it's right in the middle of the origin. We didn't go anywhere. Then we have the point 1, negative 2. First, x is left to right, 1 to the right, and down 2. And then x is 2, and y is negative 4. So x is 2 to the right, and down 4. And it should form a nice straight line for us. I did not do a very good job graphing that line right now. So it does ask us a couple questions about this graph. We can, just going to make this a little bit better. There we go. Use the graph or the equation to help us. So first it says, what is y when x is 6? Well, here's x is 6, but if I follow that down it's never going to reach up with this line. It's off the graph, way down there. So I'm going to use my equation. Instead of an x, we need to plug in a 6 right there. So y equals negative 2 times 6. Well, 2 times 6 is 12, and it's negative. So this would cross way down here at negative 12. Then, what is y when x is negative 3? Well, negative 3, we can actually look at our graph and see right here that it would cross at when y is 6. Or you can use your same equation, y equals negative 2x, but instead of x, we can plug in a negative 3. Negative 2 times negative 3 does make a positive 6. So that's how you can use your graph as well. When x is 3, we followed it to the line. Y is 6. Let's try one more. Here's another equation. Y equals negative x plus 2. If there's no number, we know that's a negative 1x, because there's 1x there. Just because there's a plus or a minus, we already know that this is not proportional. It's not going to go through the origin in the middle. So let's take a look at our equation. We have y equals negative 1x plus 2. So I'm going to rewrite that here, but instead of x, we're going to be multiplying by some number and then adding 2. First, that number is going to be a negative 2. Anytime you see an x, replace it with whatever x is. So negative 1 times negative 2 makes a positive. A negative times a negative is a positive 2. 2 plus 2 is 4. Then our next point, we're going to do the same thing. Negative 1 times x, but x is a negative 1, and then add 2. Negative 1 times negative 1 is a positive 1. 1 plus 2 is 3. Then plugging in a 0, negative 1 times 0 plus 2. Remember, I'm just restating my same equation over and over, but instead of x, I'm plugging in whatever x is equal to. Anything times 0 is 0. 0 plus 2 is 2. As you can see, there's a pattern being formed. 4, 3, 2. I can predict, if you figure out the pattern, what the next couple numbers would be. If we double check, we plug in a 1. Negative 1 times 1 is negative 1. Negative 1 plus 2 is positive 1, yep. And then negative 1 times 2 is negative 2. Negative 2 plus 2, yes, is 0. So your y's will follow a pattern as well. So let's go ahead and plot these points. X, then y, remember. X goes left to right, y goes up and down. So our first point here is negative 2, 4. Right there. Next point, negative 1, up 3. Negative 1 is right here. That's only one for some reason isn't labeled there. Then 0, up 2. As you can see, we did not go through the point 0, 0. We went through 0, 2, so we know that's not proportional. Then the point 1, 1. X is 1 to the right, and then up 1. And then 2, 0. X is 2, and then we didn't go up and down. So here is our line or our graph. It would continue on in both directions. So first, what is y when x is 3? Well, x is 3 is right here, so if we follow that to the line, it would be at a negative 1. Or you can plug it into the equation. Negative 1 times x, which is 3, plus 2. All I did was restate my equation from up there. Negative 1 times 3 is 3. Sorry, negative 3. Negative 3 plus 2, yes, is negative 1. So y is negative 1 when x is 3. And what is y when x is negative 7? Well, negative 7 here, if I follow that up, my line, it doesn't fit on the graph. So this one I have to use the equation. Negative 1 times x, and x is negative 7, then plus 2. So first, a negative times a negative makes a positive. 7 plus 2 gives us 9. So y would be at 9, which makes sense because it's just a little bit off the graph. All right, our last slide here. Not a whole lot of work. We just need to circle the proportional graphs, equations, and tables. So first, our proportional graphs, remember, go through the point 0, 0. This one does not go through 0, 0, so that's not proportional. This one does, so that is a proportional graph. 0, 0 is right here in the middle, doesn't go through it. This one, yep, goes through the origin. And this one, yep, goes through the origin. So let's take a look at our next row. It says proportional equations have no adding or subtracting. So this one just says y equals 3x. There's nothing added or subtracted, so that is a proportional equation. This one right here, it says negative x minus 8. Because it's adding or subtracting after the x, that's not proportional. This one has a negative that's not adding or subtracting here. They mean after your letter. Is there something added or subtracted? No, there is not, so that is proportional. This one, same thing, this is proportional. There's nothing added or subtracted on the end. Proportional, nothing added or subtracted on the end. This one, oh, we have minus 9, not proportional there. And same thing here, this one has plus 2. That tells us it's going to begin somewhere other than 0, 0, not proportional. So we had 4 proportional equations. Our last set here, proportional tables, have 0, 0. We looked at tables this way, 0, 0. Same thing here, just x and y, they're just turned to the side. This one doesn't even have 0, 0 here, so this is not going to be a proportional graph. This one has 0, 1.2. Nope. This one does have 0, 0. This one, ooh, we need to do a little work. Let's hold on for a minute on that one. This one, you can see, has 0, 5, not proportional. But if we look at this table right here, I'm just going to pull it off to the side. If our pattern were to continue, negative 3, negative 2, negative 1, 0 would come next. Down here, we have negative 12, negative 8, negative 4. What would come next to get to 0? We're changing by 4. We went up by 4, up by 4. We're going closer and closer to 0. If we go up by 4 more, we would be at 0. So this is a proportional graph. Let's take a look back at this one just to make sure we didn't make a mistake here. This one, 3, 2, 1, 0 would be between 1 and negative 2. So if we were to look here, 6, 5, 4, 3 would be in here. Oh, 0, 3. That is not proportional. It's not 0, 0. So there were 2 graphs, or 2 tables that were proportional there. All right, here is your homework. I believe that all the ones on your homework are pretty self-explanatory. They have one of the 2 0